So first of all, moment is defined as the force multiplied by the perpendicular distance from the pivot. Now what you guys need to understand is my moment basically force times perpendicular distance. The SI units are Newton meters, and a moment is basically a vector quantity. The reason is that, wait a second please, to refresh this. Okay. Now, something has gone wrong on this app, you know. Anyway, I don't know what I can do. Let me do it with hands then. Okay, so what I'm saying is that basically either you can have a direction which is like this, which is clockwise, usually we write it as CW, or the direction could be anti-clockwise when something is rotating. So ACW. Some people like to call it counterclockwise, that's fine as well. Okay. So when you look at an object, right? Damn. When you look at something like this, so suppose this is the pivot and you apply a force. So the force, when it acts, my goodness, the shapes has somehow gone corrupt. Oh, thank God they're back. Okay. So basically this distance is the perpendicular distance till the pivot that causes a moment, and you can see that basically this is going to just rotate like this. So this rotation that it causes is basically anti-clockwise, and you can look at it from there. Alright, now the important thing here is that if I draw the same thing and I basically put different forces, so if I put one force here, let's call this F1, one force in the middle, let's call this F2, one force at an angle, let's call this at theta, F3, and one force exactly like this, let's call this F4. Now I just want to tell you people that these forces will have a different effect on the moment. So this is the distance d2, and say this is the distance d1. It's the perpendicular one. Now, so in this one, F1 produces the largest turning effect. The reason is that basically the moment depends on the force that you're applying and the distance that you're applying. So the distance is the largest and the force is largest, and they're also perpendicular, 90 degrees. so which means that it would produce the largest effect. However, if you do F2, so it produces a smaller turning effect. The reason is that F2 is less than F1. Sorry, whether they have the same size. So D2 is less than D1. So when you apply moment equals to F2 times D2, basically the whole thing is smaller. Even if all these forces, let's do it with an example that will help. So let's suppose all these forces are 100 newtons. This angle is 50 degrees. This is also 100 newtons. This is 2 meters and this is 4. So for this one, if I calculate the moment, it's going to be like 100 times 4. So it basically gives me a 400 Newton meter turning effect, right? Now, in this one, if I calculate the moment, so F2 times D2, so it's going to be 100 times 2, so it gives you a less moment than before. Now if we talk about F3, which was angled, so basically you need to understand that it also produces a smaller turning effect. The reason is that it's not entirely perpendicular. So if it's not entirely perpendicular, what do we do then? Because if it's not entirely perpendicular, we need to figure out the perpendicular force, and the perpendicular force in this one would be just here. So basically what you need to do is you need to make a vector, which means that the real force that's acting here is going to be moment is equal to F3 sine theta, because that would cause the perpendicular moment, times D1. So if I check this, so 100 times sine of 50 times 4, let's see what it gets us. So we're gonna use the calculator for this. So 100 times sine of 50 times 4, so it's going to give us about 306 Newton meter, which is of course less than the maximum one, which is the 400 one, right? Now interestingly, F4 produces no turning effect, and the reason for this is that F4 is parallel to the line of action from the pivot. So basically what I mean by this is, like, you see it's like parallel to this, so basically it does not have any 90-degree angle to it. And if you look at the formula itself, the formula is m equals to, if I use F4 times d and then sine theta to find the perpendicular, because this angle is 0 degrees. If you add, you say, okay, I'm going to add 100 here, I'm going to add 4 here, I'm going to add sine of 0, because the angle between the distance and the force is 0. So you use this 100 times sine of 0. So basically sine 0 is 0, so it just gives you 0 moment. Is it clear, everybody? Any questions? So in order to have a turning effect, it is essential that the force and the distance from the line of action of the force till the pivot is basically perpendicular to each other for the maximum effect, right? Any questions? All right. Now, just give me 1 minute. I just need to fill up my water bottle. I'll be back. So, and then let's check what is the effect of the distance itself now. So, effect of the distance. Now, generally, when you look at, let's suppose you want to turn a bolt on your car or something. First, you try to do it with your hands. You wrap your hands around, fingers around, try to turn. You apply a force this way, and this distance is 0.02 meters, and the required moment to basically unscrew is 500 Newton meter, and then you try it with a spanner. In the spanner, you apply a force from here, and the distance from here to here is basically about 2 meters. So the required moment is the same because we are unscrewing the same thing. It's 500. So let's check what is the effect of the force. So we're going to use moment equals to force times distance. The moment was 500, the force was F, the distance was 0.02. So basically what you need is, you need to apply 25,000 newtons of force to successfully unscrew this. However, when you use a spanner, basically the moment that was required is the same, but the distance was increased, so it means you only need 250 newtons of force to unscrew this. So the reason behind this is that basically for equal moments, the larger the perpendicular distance is, the lesser effort is needed. Is it clear, Safir and Varisha? Any questions?
No questions, sir.
Very good. Now, so I basically gave you an account of how to, increase moment, how to, also understand that what is the effect of the force and what is the effect of the distance itself. Now, let's talk about balancing something, right? So we're done with forces, and in forces we have basically learned that there are basically two conditions of anything to balance, really, and those conditions are called conditions of equilibrium. So first of all, the first condition of the equilibrium is that sum of all forces is 0, which means that if you add all of them, there should not be any resultant force. So it means that it's balanced with respect to forces. But then the other thing is that the sum of all anti-clockwise and sum of all clockwise moments must be equal as well. And this is basically, this second point is also called the principle of moments that you have done in IGCSE as well. So speaking of this, then we're going to look at certain conditions. And try to understand how it affects us. first of all, second please. So first of all, I would like to tell you about the a very simple example. So suppose we have a body like this, a seesaw or something. There's one person sitting on this side, the other person is sitting on this side. This distance is 12, and meters. The weight of this person is 800 newtons. The weight of this person is 1200 newtons, and we are interested to find this distance t, right? So of course these two are the forces, and also from the pivot itself there is going to be a reaction force that will act upwards as well, just to balance out the forces as well. So the very first thing you always do is that you always draw directions. What I mean by this is that this person will try to turn this clockwise about this pivot, and this person will try to turn this anti-clockwise. And then in the first part you apply a sum of all moments about a pivot is 0. That's the first condition. So you write that sum of clockwise moments equals to sum of anti-clockwise moments. The clockwise moment in this was 1200 times the perpendicular distance t. Anti-clockwise distance was 800 times the perpendicular distance 12. So when you do this, the distance is going to come out as 8 meters. Now if you want to find r, you would have to apply the second condition of equilibrium. The sum of all forces must be 0. In that particular one, what you're going to do is you're going to write, okay, upward forces are equal to downward forces, which means upward forces, the force is only r, and downward you have 800 plus 1200. So r must be 2000 newtons. Is it clear?
Yes, sir.
Okay. Interesting. Okay, great. So now going towards the next one. Okay, so in 10 minutes the meeting might end. I don't know if we will be able to complete it in 10 minutes. So if we don't, please rejoin. Now, so so there's like one person here and there are two pivots A and B. This person has 1200 newtons force, this person has 700. Itself the plank has a weight of 800 newtons, and there are of course the reaction forces Ra and Rb also acting. Now if you basically, they have also given the distances of all of these. This is 2 meters, this is 2 meters, this is 2 meters, this is 2 meters, right? So they've given the distances as well. And basically they're like, find reaction on each pivot. Now this sort of question is a 2 pivot system, and in a 2 pivot system what you're going to do is, in step 1 just pick your favorite pivot. Okay, Varisha, are you there?
Yes, sir.
Marisha, if I say, okay, pick your favorite pivot, what would you pick? Hmm? B?
B.
Okay. So basically, she picked B. It's okay. So you're gonna write this, okay, for her only. You can also pick A if you want to. And then when you pick one particular pivot, apply principle of moments about that pivot, and just think that the other pivot is gone. Okay. Now, so if we just look at B and ignore A, so principal moments about B, so you'll see that this force basically tries to turn it this way about B, this force this way, this force this way, and that force this way. This is anti-clockwise, 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 and the last one is the clockwise force. The reason I'm completely ignoring RB force is because about B it does not have a perpendicular distance. The perpendicular distance from B is 0, as it is exactly acting on the same point as B. Okay. Now you write sum of clockwise moments equals to sum of anti-clockwise moments. So the clockwise moment here is RA times the distance of RA till B is 8 meters. Anti-clockwise moments are 1200 times 6 plus 800 times 4 plus 700 times 2. So we always take the distance from the force till the pivot. So you guys need to remember that. Any questions? Okay. Now, so then RA is going to be 1200 times 6 plus 800 times 4 plus 700 times 2. So answer this divided by 8. So we get 1475 newtons as the reaction on RB. RA, sorry. Okay. Then what you're going to do is, in the second step, you're going to apply sum of all forces, which is the second condition of equilibrium, equal to 0, which means upward forces equals to downward forces. So then the upward forces are FA plus FB. Oh, did I say RA, RB? Okay, sorry. RA plus RB equals to 1200 plus 800 plus 700. We already found RA through the previous part, so we're going to write this. Now we only need to find this. Sorry. So 1200 plus 800 plus 700 minus 1475. So RB comes out to be 1225 newtons, right? Even if you had picked A, the answers would be the same. Is it clear? Both of you? Okay, interesting. If you have any questions, anything you did not understand, like
Sure, sir.
okay. Now sometimes in the questions they might also give you like a different sort of question, like some shapes which are angled. So let's look at that example as well. So suppose you have object like this. That's put against a wall. So this point is supposed to be B. This point is supposed to be O. Then a point A, point C. And between A and B, there is a wire that is basically letting this, supporting this plank. So the weight is here, which is 30 newtons. There is a tension force here. There is an angle theta. They've given you the distances. So from B to O, this is 10 meters. And from this to C, so this distance is 6 meters. I should have made, well, it's not entirely correct, I'm sorry. Ignore the lens, please. It's like bad drawing skills. It's 6 meters, 3 meters, 3 meters. And yeah, that's it. Now, they say find tension T and angle theta. There is one more force that is acting this way. This is R. Okay. Now we got two unknown forces, which are R and T. We just need to find T and the theta, right? That's there. Now, because we don't need R, so this is a tip that always take a pivot. So you can choose any point as a pivot, but always take a pivot where an unknown and okay. So I was saying always take a pivot where an unknown and unwanted force is acting, which basically means that if I take O as the pivot, in this case, R would be entirely eliminated because it will not have any perpendicular distance to it. So then, taking O as the pivot, so what you're going to do is you're going to make the directions. This will turn it clockwise. This will have two forces, two components. So one is this is t sine theta, this is t cos theta. So t sine theta will try to turn it this way, which is anti-clockwise, and there's no other force really. So sum of clockwise.
I think your mic is off.
Okay, sorry. So I was saying that basically when you have to eliminate a force that you don't need, you take that pivot. Okay, like O, I took O because I don't want R. They haven't asked it. It's an unknown force, right? And then about O, I took the direction, so 30 newtons will try to turn it clockwise, and t sine theta and t cos theta are components of the theta, right? So I did it because I want to get the perpendicular force out of them. T is not perpendicular. This is perpendicular. So I'm ignoring t cos theta because it is basically, it does not have a perpendicular distance about the pivot, right? Do you understand what I'm saying? Okay. So sum of clockwise moment equals sum of anti-clockwise. So clockwise one is 30 times 6, anti-clockwise one is t sine theta times 9. So this comes out to be 30 times 6 divided by 9 is basically 20. And now I have two unknowns, I don't have theta and t. So I can look at the figure. The figure basically is like this, a triangle. This side is 9, this side is 10, and this is what I need. So I can simply use tan theta equals to 10 over 9 to find the angle. So the theta is going to be tan of inverse 10 over 9, and that gives us 48 degrees. So when I put it in, so t sine 48 degrees equals to 20. So t will be equal to 27 newtons. Do you understand? Please let me know if you have any questions here.
Yes, I understand.
But you sure you do?
Yes, sir.
Okay. Okay. Now, so going to so this is basically all that I wanted to do today, and then tomorrow we'll start with the center of gravity thingy, and then I'll give you a worksheet. So basically, by tomorrow, if you do